So today we're replacing the condensing coil on a Keggerator cooler. This one is made by Micromatic R134A, just 9 ounces. And unfortunately, the condensing coil has a big leak in it right in here. That's our leak. Super annoying. Don't really think that's a repairable leak, so new condenser. I could not find it the other day when I was looking for it, so I topped the system off. The refrigerant leaked out again in the course of like a week, which was quite a bummer. Came back and pressured it up with nitrogen to a really high pressure and soaped down a whole bunch of connections. Eventually found that it was leaking in this coil. And some coils you can actually repair pretty easily, but this is like a weird stamped sheet metal type design, and so I didn't think I could really fix where it was leaking up in here. So we ended up ordering a whole new condensing coil. Of course it is the same as what's here, but hopefully it will last better than the first one did, because I think the system's only like 8 years old. That is pretty long, I guess, for commercial equipment. So we're gonna unbolt it here, get it removed from the system, and installed. I actually really like how they have this fan shroud and mount. It's all one piece, and you can see it actually like pops up off of here to be removed from the coil. Kind of neat, I haven't really seen that before. So we decided to just unbraze the connections from the coil. Makes it a lot easier to actually throw the new coil in because you don't have to redo a bunch of the piping. When I started brazing in the new coil, I was actually having a really difficult time getting the braze to stick to the coil. It was sticking to the copper fitting fine, but not very well to the actual coil. I was definitely confused by this and took a closer look. Thought maybe there was an oxide layer on the new coil that I just hadn't gotten cleaned off very well. So I took some emery paper and actually shined up that connection, and that's when I noticed the color change from copper to kind of a silver. Get my magnet tool. Is this a steel coil?
Oh yeah, it is.
Goodness, that is a steel. So we actually have to use the other braze. That looked just like copper. Did you see how it looked? It was copper looking. That's actually really annoying. They had a copper coated steel coil. So I got fooled with that. This is actually a steel fitting. It's like, why isn't the braze sticking that well? We'll have to hit it again with this other type of solder that we have, because I totally thought that was copper. So as you saw us realize shortly after starting to braze this, it did actually braze, but I was like, why is it not connecting well to these fittings? And it's because it's like a lightly copper coated, it's got like a copper plating on a steel fitting. So when I grabbed that magnet, it's definitely steel. And that's really surprising to me. So I'm really glad I didn't try fixing the old coil, because there's no way I could really actually braze that. I mean, it would be possible, but it would be really difficult. So what we were using, this braze with silver in it. I think this is actually 15% silver in this stick. It just won't adhere well to the steel because of the oxide coatings that form while you're trying to braze. Versus this stuff has a flux coating on the outside. This will actually make it so we can braze nicely to that, but that's really annoying that I didn't notice that at first. So I'll have to hit both of those again with some of this stuff, and it should be fine, but not ideal. And this stuff is really splattery, so we've got eye protection. Just be careful. I think it's interesting how the braze with this flux coating on it turns the flame super green. There's probably some copper oxides or something that they've actually got in the braze coating, and so it just makes it really bright green colored. Can you smell it that time? Yeah, like it burns your nostrils.
No, I
The
actually,
flux.
I did.
It's like really blah. It must be kind of, I think it's really acidic to eat up the oxides. You can see how the connections are way shinier now. It's smoother. So we are going to definitely push a bunch of nitrogen in here and make sure these are sealed up good before we pull a vacuum. So we've got like 150 PSI pushed in there, so if there's any leaks, they should be really obvious with the soap on there. But I think we're good. See anything?
Nope.
Hit them again. Just to make sure. A steel coil. Cheapskates. That's really annoying. So steel is a really bad choice for condensing coils because it actually has really bad heat transfer compared to aluminum or copper, but it's a lot cheaper, so you can just like stamp a bunch of cheap steel and dip it in some paint, coat it in a copper layer so that it looks like copper. But that's really annoying. I think the manufacturer should be ashamed that they would use a steel condensing coil. Alright, it's reinstalled, pulling a vacuum on it, and in a few minutes here we'll charge it back up. So we added in the factory charge, the unit is running, this condenser coil is getting nice and hot for its first time ever, and the cabinet temperature is already starting to come down a little bit, so that's a good sign. No leaks, as far as we can tell. So yeah, I think we're gonna be good. And we got the insulation taped back up back there where it was opened up from where I had leak checked. And we got the condensate so it will drip into the pan there, which is important. But yeah, should be good to keep the kegs cool. Getting down there. Shouldn't be too long and it'll be good to go.